Hello, fellow mathematicians, and let us begin. So, today I have a new integral with you. This is a kind of a derivation. So, this video will all about deriving the reduction formula. And over here, the subscript I m comma n is equal to m, the power of sine, and n, the power of cosine of x dx. Now, now this video is divided into three portions: introduction, derivation, and lastly the example. So let us begin. What I have written in the introduction. In the introduction, it simply states that why or what is the use of reduction formula. The reduction formula expresses a given integral into a much simpler integral, and it always uses a simple trick of integration by parts. So we already know integration by parts, right? It's integral u dv is equal to uv minus integral v du. Okay, so we are done with this. Now let us straight away go through the derivation. So before going to the derivation, I'm going to derive a particular term which is similar to this, but what I'm going to do is I'm going to substitute n in the place of n, which is the power of cos. I'm going to substitute 1, and I'm going to find the integral of this, integral of sine to the power mx times cosine of x dx. Now over here I've already chosen the value of u, or the variable u, because in the integration by parts we need u and dv, right? And what is the remaining part? The remaining part is dv, which is equal to cosine of x dx. Okay, so we are done with this as well. So what we have to do is we have to again recall the integration by parts, because reduction formula is all about integration by parts. So what is u over here? Let us see briefly. So u is sine theta by mx and dv is cosine of x dx, right? So we can apply the integration part pretty happily. Okay, so now what do we have? Now let us take the derivative of u, du over dx. So if you have used the chain rule, you might already get the result, which is m times sine theta by m minus 1x times cosine of x. And to get v in the right hand side, we have to integrate it dv. So the integration of cosine x is sine of x. Now please take your pen and paper and please note down these stuffs that I'm going to show you now. So please copy this one. Another one is this one, and another one is dv term, and another one is v term. Okay, so if you have copied this, let us move forward. Now I have to integrate this stuff, right? And I have said that this stuff is equal to integral of u dv, where integral of sine theta by mx times cosine of x dx is equal to integral of u dv. So we can use the integration by parts. Now I have been mainly focusing on integration by parts in this video, and it is compulsory to focus on only to the integration by parts, because reduction formula is all about integration by parts. Okay, so what is u? That we have already noted down, it was sine theta by mx, right? What was v? V was sine x. And minus integral, what is v? V was sine x. What was du? Du was this term out here, which we got from the derivative portion. Okay, so we have this term. Now what we are going to do? We are going to simplify this. But how? Look at sine x and sine to the power m minus 1x. Can you solve this indices? And the answer is yes. And after you solve it, you'll get sine theta by mx, right? And as m is a constant, we can bring that m outside the integral sign. So after you do that, we'll get this result. And find a pattern. Integral sine theta by mx times cosine of x dx. Isn't this equal to I subscript m comma 1, where the power of cosine is 1? where we have substituted n is equal to 1, right? So we can substitute in this way, and after this we have this, and after we bring left hand side to right hand side and so on, we'll get this term, and this is the particular reduction formula for sin theta mx times cosine of x dx. And don't forget the integral sign. Okay, great. Now let us keep this on one side. So let us jump to our main question, which was integral sin theta mx times cos theta nx dx. Now before we do that, we have to give it a notation, right? Like I subscript m comma n. Okay, so we have this. Now let us say that we have to integrate this. Now how can we integrate this? So to integrate this, we have to divide some sections. Now remember that we have already found the integration of sin theta mx times cosine of x dx, right? So after we find some trick to bring that expressions alive, then our work is done. So to bring that expression alive, what I've done is I've just used a trick, which is cos theta n minus 1 x times cosine of x gives you cos theta n x, right? So the above statement is true with the below statement. Okay, now let us solve this. Now what I'm going to do is I'm going to show you the integration by parts once again. Over here, what is u? Now I'll substitute u as cos theta n minus 1x and dv as sin theta mx cos x dx. Okay. Now we have already used the trick before as well. What I'm going to do is I'm going to take the derivative of u. And after we do that, and after we use the chain rule, we'll get this stuff. And after we integrate dv, we'll get v, right? And remember the stuff that I've said, we are going to bring that expression alive, which is integral sin theta mx times cosine of x dx. Now we have already found that integral, right? So that is equal to v is equal to sin theta m plus 1x divided by m plus 1. Now please note down these results as well. That is u, and another one is du over dx, and another one is v. Now please copy down this in your rough paper or anywhere. Okay, so now what do we have? We again have integration by parts. So what was u? U was cos theta n minus 1x. What was v? V was this result, and what was the remaining result, which is this. Okay, so let us simplify this further. So look at n minus 1 divided by m plus 1. They are a constant, right? So we can bring them outside of the integral sign. Okay, done? Now look at sin theta m plus 1x times sin x. So we can use the indices law, right? So after we use that, we'll get sin theta mx times sin square x. Okay. Now, can we further simplify this? And the answer is yes. Look at sin square x term, which can be simplified into 1 minus cos square x. Now, after we replace that, we'll get this. And after we do some calculations, after we do some algebraic operations, we'll be left with this term. And I hope that you will get this term if you try it out yourself. Okay, so look at this thing, integral of sin theta mx times cos to the power n minus 2x dx. So isn't this the similar notation? Can we write this in a notation of I? And the answer is yes. I m comma n minus 2 is in the subscript. Okay, and this term is the well-known term till now. Okay, so after we replace those things, we'll get this term. Now please don't forget that this term is equal to I subscript m comma n. Now we can say that they both are equal, right? So this equation satisfies. Now if we look at the right hand side and the left hand side, we can just bring it to the left hand side and we'll get this result. And after we get this result, we're just going to leave I subscript m comma n in the left hand side and the other terms on the right hand side, and we'll get the reduction formula for sine to the power mx times cos to the power nx dx. So let us look at an example. It is a simple example. Alright, so what is the example? So I subscript m comma n is equal to integral sine to the power 7x times cos to the power 7x dx. Now over here, m is equal to 7 and n is equal to 7. So in the subscript term, let me replace I subscript 7 comma 7. Now the main task and the easiest task is to replace m and n in the reduction formula that we have already obtained. So after we do that, we'll get this thing I 7 comma 7 and we'll be left with I subscript 7 comma 5. So as we can also use a reduction formula out here as well. So we are going to do that. I 7 comma 5 and we'll be left with I 7 comma 3. And for I 7 comma 3 we'll be left with I 7 comma 1, and in the I 7 comma 1 we'll not be left with any I terms out there. Okay, so now what we are going to do is we are going to substitute I 7 comma 5 and I 7 comma 3 and I 7 comma 1. We are going to substitute these all terms to I subscript 7 comma 7. After we do that, we'll be left with this result. And yeah, here is your answer. And thank you for watching.